Today we're going to be looking at simplifying square roots. And so the first thing we want to work with when we're simplifying square roots is it's helpful to also know what our perfect squares are. Because if we know what our perfect squares are, that gives us some numbers that will work, that we'll know automatically we can simplify in the square root. So if we run through our list of numbers, think about your perfect squares are the numbers that square root evenly. So we could go through 1 through 12 and get our list of perfect squares by just squaring each of these numbers. Like 1 squared is going to be just 1. So we know the square root of 1 is 1. If I take 2 squared, then that's going to give me the square root of 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. So again, as we kind of look at these, we've got square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. The square root of 121 is 11. And the square root of 144 is 12. Having these lists of perfect squares, again, can be helpful depending on the method also that you use to simplify a square root. Okay, but we'll go through one method that most teachers will use. Okay, so if I need to simplify a square root, so for example, we're looking at the square root of 50. What we can do is we can start splitting the square root of 50 off using numbers that we know multiply to get to 50. Okay, so for instance, I know 2 goes into 50. 2 times 25 gives me 50. And what I'll note is that that I have this 2 as a prime number. Okay, so I'm going to build this factor tree, and I want to get it to be all prime numbers. So if it's not prime, again, prime is a number that's divisible by 1 in itself, then I want to split the number off more. So like 25, I know 25, it can split off as 5 times 5. Well, 5 is also prime, so I can circle those. So now I'm down to just prime numbers. Okay, so they have the note down here, couples go on dates and singles stay home. So after I've done my factor tree, I have all my prime numbers. I want to figure out what numbers are staying in the square root and which ones are coming out of the square root. Okay, so I want to look for pairs. Couples go on dates. So if they're a pair, then they will move outside the square root. So I have 2 5s. There's a pair of 5s. And each pair only comes out once. So one pair of 5, I'll write 5 outside the square root. And then I have this individual 2 that's left. So since it's by itself, it doesn't have a date. So it's going to stay on the inside. So we know that the square root of 50, once it's simplified, is 5 square root 2. Okay, let's look at some other problems, some other examples. Okay, so if we scroll down here, we've got a few more examples that we can go through. So the first thing that we're going to do is we're going to split off our factor tree of 200. We want to split it off as all prime numbers. So again, I've got 2 times 100 will give me 200. And 2 is a prime number, so I'll circle it. Then 100 I can split off as 2 times 50. So again, 2 is a prime number. 50 can split off. That one is going to give me 2 and 25. So again, 2 is a prime number. And then 25 can split off as 5 and 5. So I want to, each time, if there are 2 numbers that will multiply to get that number besides 1 in itself, I want to split it up. And as soon as I get a prime number, I'm going to circle it, knowing that once all my numbers are circled, all the numbers that I have split off to create, once all those are circled, then my factor tree is done. And I'm only focusing on those prime numbers when I go to put it all together. So I want to figure out, where are my dates? Where are my pairs? Okay, so I have a pair of 5s, and every pair goes on the outside, so that 5 is going to come outside. I also have another pair This 2 is going to come outside as well. And then I have this single 2 right here that will go on the inside. If it's single, it stays inside. If it has a pair, if it has a date, it goes outside. Now the question is, we have 2 numbers on the outside. So what do we do with those 2 numbers? Okay, we're going to multiply if there's multiple numbers outside or multiple numbers inside, you're just going to multiply them together. So I've got 5 times 2, which gives me 10. And so this square root of 200 will simplify to 10 root 2. All right, same with 128. Okay, I'm going to split off 128. And if the lower I keep my numbers, the easier it may be for me to think of. So I notice 128 is even, so I could do 2 times, and it's going to be 2 times 64. If you get stuck figuring out what numbers, just use your calculator. Start dividing 128 by a number, and if it comes out nice, you can use those 2 numbers to split it off. So 2 is prime. Again, 64 is even, so I could do 2, and it'll be 32. 32 is even again, so it's 2 and 16. 16 can be 2 and 8. I'm gonna run out of room here. 8 can split off as 2 and 4. And then 4 will split off as 2 and 2. You do not have to use 2 every time. I'm just using small numbers so that, especially for someone that will maybe struggle finding their factor tree, you can really stick to those low numbers if you want and just keep moving. It just kind of builds a longer factor tree a little bit. All right, so I'm only focused again on all my prime numbers that I stopped at. So those circles kind of help point out the numbers I'm focused on. And I just want to find all my pairs. So I'll set up a blank one over here that I can use. Here's one pair of 2s. So I'm going to put a 2 outside. Here's another pair of 2s. So again, I can put another outside. And remember, since there's multiple, there's one already there. I'm going to go ahead and put a multiplication symbol there. I've got another pair of 2s, so I need to multiply by 2 again on the outside. And then I have this single, so that will stay inside. So remember, each pair only gets written once. I have 3 pairs of 2s. So I'll have 2 times 2 times 2 on the outside, and only one single 2 will be on the inside. 2 times 2 is 4. And 4 times 2 gives us 8. So this will be 8 square root 2 to simplify. All right, so what about, for example, 4, we actually already have a number outside. That 2 is outside. Okay, and then I have 54 inside. So what we want to really do is I might set up my blank one that I'm going to start reducing with. And I might make a note, hey, this 2 is already outside. So when I go to build my new one, I'm going to go ahead and write that 2 already here so I don't forget it. So I've already got a 2 here. I need to work on the inside to see what pairs I can pull out though. But I'm just putting this original 2 out there so I don't forget about it. And I'm only going to focus on that 54. So how can I split off 54? It's even. 2 times 27 will give me 54. Now 27, I can use 3. 3 times 9 gives me 27. And then 9 can be 3 times 3, which I forgot to circle my prime numbers as I go. But notice I'm down to all prime numbers, so I'm going to look for my pairs. I do have a pair of 3s, so that 3 will go out. Now remember, we had this 2 from the original problem already outside. So since I'm doing another outside number, I'm going to multiply those together. And I have a single 2, and I have a single 3. So since there are multiple numbers inside, again, I'm going to multiply those together. So 2 times 3 gives us 6. So we'll have 6 square root 6 as we reduce. So to see those steps again, if I look at example 5, we've already got a 2 outside. So I might put that 2 outside with a blank square root as I go to reduce here in a minute. And then I'm only going to focus on that 4. Or sorry, not the 4, the 48. I'm going to focus on that 48. Now, to see how it doesn't matter if I just use low numbers or I use other numbers that come to my head, let's use some bigger numbers with 48. I know 6 and 8. 6 times 8 will make 48. So I could start there. Okay, if I start there, neither of those are prime, so then I'm going to split both of them off instead of circling one of them. So 6 can be split off as 2 times 3, which are both prime. And then 8 can split off as 2 times 4. 2 being prime, but 4 can still split off as 2 times 2. Okay, so instead of circling one every time and splitting off the next, I end up just having to split off both numbers and continuing forward. But again, I'm circling my primes as I go so that I know when I'm done. So now we're going to look for pairs. I've got one pair of 2s here. So that will go outside with the one that's already there. I actually have another pair of 2s here. They're a little disconnected here. But these pairs of 2s, so I kind of ran out of room, so I'll put times 2 down here. So 2 pairs of 2s. We also have this original 2 that was outside from the original problem of 2 square root 48. And then I have this single 3 right here that has to stay on the inside. Okay, so 2 times 2 gives me 4. Times 2 gives me 8. So this is going to be 8 square root 3. Okay, so as you simplify square root, you're doing the same steps every time. Do your factor tree. Any pairs will move outside, and any singles will stay inside. And if you have multiple outside or multiple inside, just make sure to multiply them together. And if there wasn't a number already outside, make sure to just don't forget about it. Make sure you leave it where it was. All right. Very similar problems, but something to think about. So what if we have to multiply 2 different square roots? Okay, well, this is very straightforward in the sense that you just multiply them together. You do exactly what it tells you to. So both the 8 and 2 are inside the square root, which is what we want. So since they're both underneath the square root, then I can follow my multiplication symbol. So I'm just going to do what is the square root of 8 times 2. 8 times 2 gives me 16. So now I'm at the square root of 16. Well, if we remember from our list above that we made of perfect squares, if we look back up here, the square root of 16, was 4. So I don't even need to do a factor tree. I can go ahead and see that the square root of 16 is 4. So I can just say my answer is 4. What about example 7 where there's numbers outside? Okay, I can follow my multiplication symbol still, but again, I need to focus on what's outside together and what's inside together. So if I was actually going to put this together, I'm going to have 3 times 6 on the outside, and on the inside, I'm going to have 2 times 10. So 3 times 6 gives me 18. 2 times 10 gives me 20. Now remember, we always still need to reduce our square root. So I want to do a factor tree on that 20 to see if I can reduce it. But since I have an 18 already out here, I want to go ahead and build the one that I'm going to work to reduce, just so I don't lose track of that 18 after doing my factor tree. So 20 can be split up as 5 times 4, and 4 can be 2 times 2. So as I get those 2 2s, my 2 prime 2s, I know that's my pair that moves outside, and my 5 is a singleton. It will stay inside. Then I just need to simplify. 18 times 2 on the outside is going to give me 36 square root 5. Okay. So all you're doing is you're multiplying the outsides together, multiply the insides together, and then reduce like we did on the front side of the notes. For example 9, remember, so this is saying the square root of 7 squared. Well, remember, squaring is just multiplying a number by itself. So it's saying, what's the square root of 7 times the square root of 7? Well, since they're both inside, I'm really just saying, what's the square root of 7 times 7? And we know 7 times 7 is 49. So what's the square root of 49? Okay. If we ask ourselves the square root of 49, we could go back to the front. Okay. If we look at our list of perfect squares, we actually see that one. Square root of 49 is 7. So when I come down here, I will know the square root of 49 is just 7. My answer is 7. So sometimes our square roots will come out nice when we simplify them. We won't actually have a square root in our answer anymore. Something to note, though, too, if you notice, basically what we're saying is if we square a square root, remember, these are opposites of each other. If I square a square root, those cancel each other out and just give us the number that's inside the square root. As I mentioned that, though, I would tell you to be cautious of example 10, where we have 4 square root 7. Because again, if I'm squaring something, I'm saying multiply it by itself. So what's 4 square root 7 times 4 square root 7? So yes, squaring a square root will cancel that square root so that will become 7. But remember, you're also squaring that 4. I still have to do 4 times 4. So if I make this look like we did in example 8, when I rewrite that, I'm multiplying the outsides together and I'm multiplying the insides together. So 4 times 4 gives me 16. Square root of 7 times 7 gives me 49. Well, remember, if I focus specifically on the square root of 49 right here, well, we know from our list of perfect squares, the square root of 49 is just 7. The square root will go away completely, which is why, remember, when we squared that square root of 7, we knew those should cancel each other out and all I should have left is 7. But you have to square that 4 that we originally had as well. And 4 squared gave us the 16. So what I want to do in the end is I want to know what is 16 times 7 to get my final answer. Okay. So just be cautious. If there is a number outside that square root, you have to square the number outside. And then when you square the number that's inside, it will get rid of that square root. So our final answer, 16 times 7, should give us 112. Okay, so the last portion of these notes is just a simplification part of fractions that we need to make sure we understand. Okay, this is something that will be helpful for the next lessons. Okay, first off, if you're square rooting an entire fraction, we can rewrite that really so that you just have the square root of the top number over the square root of the bottom number. So we might want to separate it out first so that we can see what we have individually on top and on bottom. Okay, there's a rule that we cannot have a square root in the denominator. So if we are not allowed to have a square root in the denominator, we have to get it out. So in order to reduce that, in order to get the square root out of the denominator, you're going to multiply the numerator and the denominator, the top and bottom, by the square root that is in the bottom. So in my denominator is the square root of 2. So I'm going to multiply top and bottom by the square root of 2. And this brings us back to, example 7, 8, 9, and 10, where we had to multiply square roots together. So your top, we're multiplying the insides together, becomes square root of 3 times 2. And your bottom becomes the square root of 2 times 2. Well, this gives us the square root of 6 over the square root of 4. Now remember, we're not allowed to have the square root in the denominator. But if we notice, to simplify, what is the square root of 4? Well, the square root of 4 is just 2. So now I have the square root of 6 over 2, and that gets rid of the square root in my denominator. So that is a rationalized denominator. It is a simplified fraction. So the key thing is, just like when we square a square root, if we multiply a root by its same number, so square root of 2 times square root of 2, it will make it to where the square root goes away, and that number just becomes your denominator. All right, so let's look at example 12. Okay, I would first start out and I would split this up. I've got square root of 7 over square root of 80. Now there's a couple ways we could do this. We could simplify the square root of 80 first and then go from there. Or I can go ahead and multiply that up and then reduce. It's really up to you. What I'm going to do to keep my numbers smaller is I'm going to simplify that square root of 80 first. Okay, so 80 I can split off. 7 is already prime, so I'm not going to worry about simplifying the square root of 7 up top. But 80 I can. 2 times 40, and 2 is prime. 40 can split off as 2 and 20. And 20 can split off as 2 and 10. And 10 can split off as 2 and 5. So I'm getting all my prime numbers so that I can simplify the square root of 80 first. When I do that, I've got a pair of 2's here and a pair of 2's here with a single 5. So square root of 7 stays the same. And this is going to become, I've got one pair of 2's, a second pair of 2, and a single 5. So 2 times 2 on the outside gives me 4. Remember, if there's multiple pairs or multiple singles, just multiply them together. Becomes 4 square root 5. So I'm replacing the square root of 80 with 4 square root 5. Here's why I'm going to do that. If I reduce now, remember my rule was to rationalize the denominator, I'm multiplying both the numerator and denominator by the square root that's in the denominator. So I don't need to multiply top and bottom by 4 square root 5. I'm just going to multiply by the number by the square root. So I'm multiplying top and bottom by the square root of 5. I'm ignoring the 4 when I multiply the top and bottom. Okay, so I'm going to come down here to keep writing this. So I've got the square root of 7 over 4 root 5. And I'm multiplying top and bottom by root 5. Multiply the insides together. So 7 times 5 gives me the square root of 35. There's no number outside that I multiplied originally on top and bottom, but there was an original 4, so that 4 is going to stay. And the square root number, 5 times 5, I'm multiplying those insides together, becomes the square root of 25. Well, remember, we got the square root of 35 from prime numbers. Okay, the reason I simplified early is because since I got everything down to prime numbers as it is, I know that numerator I'm not going to have to reduce. Okay, the numerator, since I used 2 prime numbers to get my new numerator of square root of 35, I don't have to reduce it. So 35 will stay where it is. But remember, square root of 25 is just 5. And then 4 was on the outside. So if this 5, if my square root went away and it's now just 5, I need to do the math here. I've got 4 times 5, which is really just 20. So my denominator, because in order to reduce this, my denominator cannot have a square root. This gives me the square root of 35 over my denominator, which just became 20. So now my square root is simplified. Example 13 is really quick. And this is your last one. The trick they're trying to throw at you is I have a square root in the bottom. It is simplified already because 2 is a prime number. So I'm going to multiply top and bottom by that square root. The trick they're trying to mess you up on is in the numerator. I have no square root in the original numerator. It's just 3. But I'm multiplying by a square root. So remember, 3 is on the outside, but the 2 is on the inside. So I do not multiply them together to make 6. I'm multiplying. If I wanted to see an outside number on this, it would be a 1 here. So 3 times 1 just really gives me 3 on the outside, square root 2 on the inside. So my numerator is going to become 3 square root 2. All right, then I'm multiplying the bottom. Square root of 2 times square root of 2 gives me the square root of 4, which we know the square root of 4 is just 2. So again, couple reminders. When you're reducing square roots, one of our methods is to use a factor tree to reduce those square roots. Dates go on the outside, singles stay on the inside. If there are multiple dates or multiple singles, then you're going to multiply them together. When you multiply square roots, you're going to multiply the outsides together, and you're going to multiply the insides together. Reduce afterwards to make sure it is fully reduced. When you're squaring a number, remember you're multiplying by itself. So you can just rewrite it as the number multiplying by itself. And then when you need to rationalize a denominator, remember when you have a fraction, you cannot have a square root in the denominator. So you have to multiply top and bottom by that square root that's in the denominator so that the square root will go away in the denominator. Okay, you can always reduce your fractions at the start and then go to simplify your fraction, or you can reduce afterwards. It's up to you. If you have questions, be sure to ask your teacher, and I hope this helped.